2, 1, go.
All right. So, hey everyone, welcome to today's VMware code session. My name is Barathi, and what we will be talking about is multi-tenancy within Kubernetes. So, a little quick introduction of myself. Right now, I work as a cloud strategist supporting enterprise accounts, primarily in the northeast part of the United States. I'm also part of the ambassador program for the Office of CTO at VMware. And I've been sort of lucky to work in a few different areas at VMware. So prior to taking on my current role, I was a staff systems engineer for the NSX product line, and I've also worked as a cloud services advocate as well. These days, my primary area of focus is mainly around networking, hybrid cloud, and I focus a lot around how we go to market with our software-defined data center solutions and also our modern application stack. So just wanted to set the stage a little bit because, quite frankly, we'll be covering a lot of topics and some concepts which are realistically very deep. And if you were to sort of individually take a lot of these ideas and concepts there, it's going to take quite a bit of time to get familiar with. So just to give you a little background as like how I came up with the session and why this was important for me to understand was, I was working with a customer and they sort of understood the basics of Kubernetes, though that wasn't the interesting part. So for me, the interesting part and something that I needed to personally sort of get up to speed was understanding multi-tenancy and how that sort of translates inside the Kubernetes domain. So given we have a little bit of limited time here, so I'm going to be skipping over a lot of the Kubernetes fundamentals, so I'm not going to be talking about how Kubernetes is getting set up and so on and so forth. I also assume that a lot of you folks who are watching are going to be somewhat familiar with these aspects, but if not, definitely, there's a lot of good content that, we've put out there in terms of basics of Kubernetes in general. Also check out Kube Academy that we have out there. So the way I've sort of framed the session out is, more or less sort of to give you a broad and a quick summary and overarching vision of how you can think about multi-tenancy inside Kubernetes. So I also encourage you after this to sort of dive a little bit deeper into each of these topic areas as you sort of go on this journey. So just to level set, I think everyone sort of has been familiarized with understanding how we're going, what a monolith is and what a microservice is. But if you're sort of relatively new to the space, just to sort of level set, when we talk about a monolithic application, these are sort of self-contained applications by and large, right? They typically have very long release cycles, and you have to go through change windows and so on and so forth. In terms of availability, if there is a bug or an issue with the application stack, there's a tendency, because it's a monolithic self-contained sort of stack, there is a tendency that it's going to probably bring down the entire application, right? And also, when we look at it from a technology stack point of view, there's obviously a long-term commitment to building the stack itself. Whereas if I contrast that with a microservice style architecture, microservice style architecture is by and large they're designed to be small interconnected services, right? They're largely independent, where each of these teams can sort of build, update, run, manage all these things independently, right? And just the inherent nature of how they are built, the faults can be quickly isolated because they are isolated from each other, right? So that's kind of the basics of how a monolithic service and microservice sort of architecture is built up. Now, when we talk about containers in just as a fundamental piece they give you the ability for each of these microservices to be sort of built independently, developed independently, deployed, lifecycle management. You can sort of do that independently at this point. And one of the big reasons why containers is very attractive to a lot of people is the reason that they're extremely lightweight and offers customers the ability to be portable, right? So gives them the quicker deployment sort of methodology. Now, where Kubernetes really sort of steps in is being able to offer an orchestration layer for these containerized applications. Now, I want to basically focus on 3 to 4 areas that, where what I primarily like to highlight is what does Kubernetes really solve for from an application deployment stack. And what it really is able to do with there is, so number one is around, if you think of application reliability, right? Uh, Kubernetes ensures that a failed pod can always get restarted and it stays up at all times. That's just the way the scheduling mechanism is built, right? Same thing, like if there's a failed node, can I basically take those pods and reschedule those pods? That's the application reliability side of things, being able to ensure that the desired state that I want is always maintained. So that leads me to sort of number two is where uh, I'm basically just providing the desired state. I'm not ensuring. I'm just basically providing that all through to the Kubernetes API, and that Kubernetes API and the scheduling mechanism sort of ensures that this stays up at all times. The third thing is around having a common standardized sort of API framework to sort of manage this distribution application deployment and all the infrastructure elements that sort of go with it, right? So if I need to get a node policy, I can do that through YAML specification. Same for a load balancer. I can use the same declarative approach that I've been using to deploy my application stack. I can sort of use the same thing to also drive some of these other components. And lastly, it really takes the heavy lifting out of getting a sort of containerized application into production for the most part. So now taking this one step further is this is where some of these primitives around sort of multi-tenancy sort of start to come in. Like if I need to deliver a multi-tenant application however we want, and we'll sort of get into a lot of the specifics of how this sort of works, but this is where it sort of gets interesting if you think about it. So let's start with just defining what multi-tenancy is, because you can ask three people what multi-tenancy is, and you're probably going to get five answers, right? So the way we can think of multi-tenancy in this situation is isolation between tenants within a cluster, right? So let's unpack a little bit of what these individual terms are. So just to sort of level set there. It's important to understand what we mean by isolation. Is it physical? Is it virtual? And also something that I can also ask a lot of times is like, why do you need this isolation? Is it for regulatory reasons? Is it for security, SLAs, and whatnot? The concept of tenants is also sort of interesting here because tenants can also mean a line of business for an enterprise. It can mean external customers. So what is the definition of a tenant is sort of important to grasp here as well. And lastly, we'll largely focus the talk here around how do we provide this sort of isolation for tenants within a single cluster concept, meaning within the confines of a single Kubernetes cluster and creating isolation and maintaining sort of these resource isolation that we need, right? So one thing I want to also highlight here is not to confuse IaaS multi-tenancy with Kubernetes multi-tenancy, right? Because these are sort of different things here. So one aspect I want to highlight here is like if you look on the left side of this diagram, the left side of the diagram is basically highlighting a shared infrastructure layer or an IaaS layer and an SDDC layer that's sort of underneath the hood. But then you have a single Kubernetes cluster, and the tenancy definitions is based on a namespace construct here. So you can have tenant A, tenant B, and so on. Or you could have a shared or dedicated infrastructure as it's shown on the right side, and you could have individual Kubernetes clusters. So we'll focus more on sort of the former aspect, so that's what we want to focus on, so that we have a shared infrastructure concept, a shared Kubernetes cluster, and then sort of the namespace isolation elements to sort of built on top of it, right? Another aspect here that it's sort of important to consider is, what kind of code elements are going to be brought in, and what is the end user expecting in terms of running? What kind of code are they going to run on these environments, right? So I work with customers who are on sort of all aspects of this spectrum, all the way from the far right to the far left, right? But it's important to also consider that as you sort of go through this process of defining this multi-tenant architecture for yourself. So I like to sort of put them into three buckets, if you were. So one you can have sort of your trusted bucket. So this is where the code, the image, everything is sort of audited, it's verified, the repository it's going to be deployed from is verified. These are largely trusted components, right? So the typical example that you can think of is like your regulated enterprise or like an air-gapped environment, right? These are that sort of falls into that trusted bucket. If I go into the second sort of semi-trusted bucket, that's largely like the code image. These are from verified repos, but there may be third-party extensions that have not been fully audited and vetted. So that's where we find that majority of the people sort of lie today, right? And then lastly, you can have code image. Everything is from an unverified repo. Like, and the assumption there is that this is just probably malicious code at some level, right? So typically think of this as like, sandbox experimental kind of environments is what you would sort of think about in that scenario. So a couple of common scenarios that we've come across in terms of how we can define and see what multi-tenancy sort of looks like, and we'll kind of walk through these different scenarios in the next couple of minutes. So the first one on the far left is your typical enterprise use case. So you have a cluster admin or a platform engineering team that is doing the heavy lifting of actually setting up the Kubernetes cluster. All of that stuff is done by a cluster admin and a platform team. Now, the users, they can be line of business users or whoever or whatnot, they have tenant level privileges to a specified defined namespace. So their roles and RBAC, we'll talk about RBAC in subsequent slides, but just know that that's one model where all they're scoped to are individual sort of namespaces, and that's one of the models that we kind of see very frequently. The second one that we sort of do run into quite a bit is around a SaaS-based sort of approach. This is slightly different where, frankly, I mean, if you think about it, the consumer is consuming the application. They're largely unaware of the mechanics of what lies sort of underneath the hood, right? So they're going to be able to access the application through some kind of proxy, load balancer, some mechanism like that. But the service consumer or the consumer of the application itself largely doesn't need any sort of read-write access to the actual pods or anything that are running underneath the hood. They're largely just accessing the application, and the cluster admin takes care of all the heavy lifting from a Kubernetes standpoint, right? And then the third model is around, if you think of a container as a service sort of model, where each user and line of business entity sort of gets their own Kubernetes cluster and has full admin rights to sort of building everything that they want on that cluster. So their role and responsibility is sort of scoped out to the actual server itself. So the big difference between the enterprise use case on the far left and the far right is either whether you have a shared control plane or you don't, right? That's sort of the way you can sort of think about this example. So on the surface, when we actually start to look at this, a single cluster model definitely looks tempting, right? So it's less overhead. I just have a single cluster. It's easy to manage, shared control plane. All the things can be reused. It's very tempting, but something to think about in the long run is, you will run into a situation where you will need to manage more than one cluster. That's just the law of how these things sort of work out. So things to think about is like, how are you going to do sort of multi-cluster management in the long run? How do we sort of allocate the right compute resources for these individual clusters, managing the compute resources, capacity planning for these nodes, and so on and so forth, and also making sure that the cluster configuration stays consistent and sort of avoiding snowflake environments that you want to think about. So this is something where I would highly encourage a lot of folks to sort of check out something like tons of mission control that can potentially help. It really is able to bring together the multi-cluster management capabilities, regardless of where these clusters run, whether it be on premises or be it in public cloud. But being able to provide a consistent layer of management capabilities across the board. And so I highly encourage you to investigate tons of mission control. Chances are very high that this is something that most customers are going to need at scale. So just to go through like a little bit of a pros and cons in terms of what the cluster level namespace, cluster level tenant sort of brings to the table versus a namespace per tenant sort of brings to the table. Obviously, with a cluster per tenant, you get strong isolation. It's a dedicated sort of control plane. It's self-contained, so you get all that out of the box. So that's a given. Obviously, the things that you want to be able to think through are how do I sort of manage the multi-cluster environments at scale, right? Also, something to think through is there are potential situations where you're going to run into trapped resources and resource isolation. So that's something we want to think through. Now, if I contrast that with something like a namespace per tenant sort of model, uh, Kubernetes policies can be namespace scoped, and we'll talk about that in a couple of slides. We can reuse extensions, control plane components, and so on and so forth. But in order to enforce like strong isolation boundaries, if that is the requirement, it needs some level of tooling, and we'll have to get into a lot of heavy engineering to actually sort of accomplish that. Another thing to also sort of keep in mind is like, these are largely Kubernetes concepts that we're talking about, but underneath, we still need a robust sort of IaaS SDDC layer that's going to be hosting these things. So as we sort of think through this, something for you to think through is also, we will eventually run into configuration maximums for these IaaS layers and SDDC layers. So like things like, what is the vCenter limit on host, VMs, and so on and so forth. On the networking front, like, how many logical networks are we going to look at scale? How many routers, security policies, how many of these things, NAT policies are we going to do? Those kind of things. Similarly, on the storage front, all of these things need to be sort of weighed in when we sort of make this decision of going cluster per tenant or namespace per tenant, and what kind of multi-tenancy model are we sort of looking at in the long run. So let's look at some of the out-of-the-box things and primitives that Kubernetes sort of brings to the table. So there are a couple of key primitives that are important to understand before we get into what RBAC means to Kubernetes and how Kubernetes sort of breaks these down, right? So there's three main things to sort of understand. So there's number one, which are subjects. Subjects are basically, if you translate it to plain English, it really translates to a set of users and processes that want access to the Kubernetes API. That's the simplistic way you can think about it. Now, the second part is around resources. Like, these are your Kubernetes API objects. So think of things like pods, deployment, services, nodes, whatever you have. And then verbs are basically actions. So these are typically your current operations. So like things like get, watch, create, delete. Those are your what are the actions I want to get out of it, right? So if I break this down, we talked about how do we accomplish some of these RBAC controls. So Kubernetes largely breaks this down into the following. So number one is a role. A role is simplistically, what can you do to a set of resources is what a role definition is. That is typically assigned to a namespace entity. Similarly, similar to roles, you also have something called a cluster role. A cluster role is similar to roles, but it is scoped to a cluster instead. So that's why the name cluster role. Once it is scoped to a cluster, what it means is that you have access to all the namespaces that are permissioned within that cluster itself. And then similarly, now you have something called a role binding. A role binding essentially grants permission to users and defines what the user can perform. Similar to what the roles entity is, the role binding entity is scoped to a specific. You can scope it to a specific namespace. Similar to cluster role, now you have something called cluster role binding. Very similar to role binding, except that it is permission to essentially all namespaces sort of within the cluster itself. Frankly, Kubernetes networking policy is extremely deep. Not to scare you away or anything, but it's just a much more deeper topic than what I can sort of convey in a couple of slides. So just know that when Kubernetes networking policy at a 10,000, 50,000 foot level is really how you can define how pods can sort of communicate with endpoints and sort of other pods at that point. The default behavior for a Kubernetes network policy is such that it's able to accept traffic from any source. So what we do is basically create network policies, and we use labels to select the pods, and then we would define the rule. So the rules can be basically, they basically say things like, hey, this traffic is allowed and denied, and so on and so forth. Now, highly do recommend to change the default behavior. So there are some out-of-the-box things that you can do. So things like a default deny all or an allow all. You can only allow egress or ingress and so on and so forth. So there's a couple things that you can do in order to control the default networking behavior itself. We'll talk a little bit about admission controllers a little bit down the road, but know that pod security policy is an implementation of one of the implementations of the admission controller itself. But it's really, I would like you to think about it like another tool in your arsenal of how you can allow or deny what pods are going to get scheduled and things like that. But pod security policy, or PSP, is really a cluster level resource to manage the pod specification. So what that means is we can define a set of conditions that a pod needs to match in order to get scheduled. So things like, what you can define are, is this a privileged container? Is it using host volumes? Is it using network port protocols and things like that, right? So these are things that it must match, and the only once it matches that it's going to be allowed for it to be scheduled, right? PSP in general is an optional element, so it's not implemented by default. It is implemented as part of an admission control. It's implemented as an admission controller, but it is something that would be recommended in order for you to, if you are especially doing multi-tenant sort of infrastructure, multi-tenant architectures, definitely recommend that this is something that you should consider. And lastly, the common implementation for PSP is via RBAC object. So role bindings, which we talked about in the last slide, that's typically the implementation for this. Another thing to also consider here is resource quotas. So, I would assume like a lot of the folks watching are familiar with, quotas, limits within vCenter, vSphere, things like that. Kubernetes also allows you to set resource quotas for the pods and so on and so forth. I mean, basically what it's doing is it's ensuring that there's a fair share of resources that are shared across all these namespaces and all these elements. So if you think about a basic workflow, is like, as an admin, I would create a resource quota for a namespace, and the end users or the line of business would come and they would schedule their pods and services inside the namespace. Now, this is where the system would sort of start tracking what the resource consumption is against the specification. So if there's a mismatch, now we can sort of ensure that the resources are always maintained for that specification. You'd largely create this for things like memory, CPU, storage resources, and so on. But in a lot of cases, like, when pods are actually scheduled or pods are created, they don't have a specification as such. So this is where something called the limit range option is sort of helpful, is because what it does is it helps enforce a minimum and maximum for the compute storage resource requirement, and it helps enforce that along the way. So a couple things to sort of consider, right, as we sort of go through this is ideally, what we recommend is that, you want to be able to categorize your namespaces into ideally the following. So a system namespace that is sort of exclusively dedicated for system pods, a service namespace that is dedicated for services, and this is accessed only by services in other namespaces. And then a tenant namespace. A tenant namespace is essentially something that is just mapped to a line of business or a tenant, and they spin up the apps that are specific to them inside that. Now, tenants overall could potentially have and own more than one namespace. And in order to enforce where they are scoped and how they would run, you would sort of enforce that through the RBAC methodology that we covered in the earlier slide. So that's how you could sort of categorize and build out these namespaces. The cluster persona is also something kind of interesting, where you want to be able to at least think through and break up the who can sort of access and what level of access do they have into the cluster into sort of largely 4 personas, if you will, right? So number one is the cluster admin itself. They typically would have full read-write access for all cluster resources, including stuff that's owned by the line of business users and tenants themselves. So this is like your super user kind of mode, right? the second one is like the cluster viewer. So someone who can just do things like read and view cluster resources and also view other tenant-owned resources, but no 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 write capabilities or no way that they can make changes to the cluster itself. Same thing on the other side. If you have a tenant admin, these are they can create new tenants. They can read and write capabilities that are scoped to the tenant, but they cannot do things that are cross account, right? And same thing on a tenant user, so they can read, write resources, but not make any major changes beyond that. Pod networking policies. Again, I think we talked about this in a previous slide, but something you want to be able to sort of think through and consider is implementing sort of a default deny all. I mean, that's sort of the best practice that we want to be able to follow, where it basically avoids accidental, traffic that's destined to other namespaces and pods in those namespaces and things like that, right? A few things that you may want to also think through, and I'm going to speed through this a little bit, but something that's worth mentioning in terms of advanced concepts that are available in something like our PKGI product, formerly known as VMware PKS, is we offer NSXT for container networking in this stack, right? Something you can do here, and as you can see through the diagram, is we can sort of break this up into different components where you can have a shared tier 0 router for management purposes, and then each individual tenant gets their own dedicated tier 0 router per se. Now here in this scenario, the Kubernetes clusters are deployed in complete isolation. So each tenant gets their own tier 0 router, they get their own sort of load balancer segment, and so on and so forth. Again, now this can get very complicated very quickly, obviously, but something to think about is also how you can do various networking topologies in this scenario, where you can do things like you can have NAT, no NAT style router topologies, etc. Right? Again, this is very deep, but it can get very deep in itself. So, highly encourage you to sort of dig into this option further and look into what we can do from a networking perspective inside the NSX platform as well. So we talked about pod security policies or PSP a couple of minutes ago, but in general, admission controllers are something that's an optional element. It's not turned on by default, but I think it's worth enabling, especially at scale when you're looking at a multi-tenant sort of infrastructure, multi-tenant architecture for yourself. But basically, at a high level, what is an admission controller doing here? Admission controllers are in place so that it can sort of intercept the requests that are made to a Kubernetes API prior to the object being persisted, but post authentication. So that's where it sort of intercepts it and sees if it's something that needs to be sort of deployed or not. It can also do a couple things, right? So one is it can obviously just do the validation, but it also can mutate the object itself in order to allow for its admittance. What do I mean by that is it can make some validation checks and say, hey, this is going to be allowed. But if I get something which is not as per the specifications, it can mutate that object and then allow admittance. So why would we want something like admission controllers in general? So what you can do is things like, you can enforce security guardrails, for example, and you can say, hey, go pull the images only from a specified registry. Again, in terms of governance, I can enforce hey, all my objects that are going to be provisioned need to have appropriate labels, for example. Config management. You can also sort of fix the image sizes and so on and so forth by adding resource limits and so in this thing. The best example is, again, we talked about it a couple minutes ago, is leveraging something like a pod security policy in order to sort of enforce this. And lastly, we covered sort of resource quotas previously. These really allow you to sort of control the total resource usage across the entire cluster. And these are for tenant scope namespaces. So here's an example of how you can sort of do that through the YAML specification. And we also talked about how you can use the limit range option to sort of force the default sizing when pods really don't have any compute requirements as such. So in order to sort of wrap up, what I would highly encourage you is, a lot of the stuff that I pulled together for this slide was is stuff that was found on the official Kubernetes documentation. So definitely check out kubernetes.io and the documentation there. There's a whole special interest group that works on multi-tenancy in the upstream Kubernetes community, which is the Kubernetes multi-tenancy SIG. So definitely check out some of the documents there. I've linked your GitHub page for them. And also check out the Tonsor portfolio itself. Tonsor portfolio is got a bunch of different services that are out there that cover a lot of these elements. So highly encourage you to check out some of these elements out there. So with that, let me check if there are any questions in the chat window. So if there are no further questions, thank you again for listening to the session. If you have any questions, comments after this, please feel free to reach out to me via Twitter. It's at Prabhu_B, PRABHU_B. So happy to field any questions offline after we're done. So with that, thank you very much.